Hi and welcome to TRX Bench. Today, as you already can see, on the bench we have an Icom. It is a IC-1271E and that is a 1200 megahertz all mode radio. Okay, and I got here a full description with the radio. So the old man is stating that this radio has been in store for the last couple of years, and now he wants to use it again. And he is telling us that yeah, the radio is not fully delivering its rated output power, especially on 1296 megahertz, and that is something he wanted to get back to full output power. So full output power of this radio should be 10 watt, and yeah, you see, I've already dialed in our 1296 and I've set the radio to FM, as you can see here, and yeah, we can directly test what's going on because I've already set up my test equipment, and yeah, we will immediately see what's going on here. Okay, so first check, let's see what our internal meter is telling us. So I have put here the RF power to full power, so that means clockwise. Now I switch it to transmit, and you see that the transmit button is coming up, and well, yeah, according here to our meter, it is 9 watt output power, but you know, these meters are really not very accurate, so we cannot rely on that. So let's check with a little bit more accurate test sets. Okay, so let's take here our Rohde & Schwarz level meter, and let's do exactly the same, and let's see what we have. And yeah, so what you see, we have 10 watt, so that is obviously just fine without a problem. But what we need to say is that we have here our test head directly connected here to the radio, or better to the PR output, and that means we do not lose power on our antenna cable. And yeah, remember, if we are dealing with high frequencies like this, we really gonna lose a lot of power simply on here on our antenna cable. And let's compare if we test, yeah, through only this wire here, right? So I have here connected my normal antenna wire, my lap wire, to the radio, going up to my yeah, let me rearrange here my camera, so then it's much better to explain. Yeah, I have connected it to my Rohde & Schwarz SMDU Z1, which can also read our power. And so we are going here into our SMDU over a 10 dB attenuator, so not that you get confused here by our automatic setting. That means if you see the LED for 1 watt coming up, means with the attenuator that it is 10 watt what we are reading full scale, right? Okay, so let's do here exactly the same, and let's see what that means. So we are already losing here half a watt, simply because we have this little wire here from the radio up here to the SMDU, and there you already can see how much you're simply losing by a simple cable. So you always should use high performance wire with low attenuation with high frequencies. So that is crucial if you're dealing with high frequencies, because the way up to your antenna is much longer than what we have here in our test configuration, right? And because we are already checking out the radio, let's see what the frequency is where the radio is transmitting on. So we have set our radio to 1296, and that is what we should be able to read on our counter. So let's transmit, and yeah, what we see is 1295 995, and then 200. I mean, it's creeping up a little bit here. That means 240 hertz, and we should see 1296, and that means we are off what is it, 800 hertz. So let's see if we can go up here with our resolution. Yeah, and you see 995, and it should be 1296, and that means we are heavily off here. We are really off frequency here. Yeah, so really we are heavily off. So this here is, yeah, we have increased our resolution. So of course now we can read 1295, 1 gigahertz, 200 mega, 90 mega, 1 or 5 mega range. And now I increase here the resolution so that we get more digits. And what you see when we go down here, 900 kilo, 90 kilo, and that is then 5 kilo, yeah, and 215 hertz. So that means we are almost 5 kilohertz off, which is really quite a lot. And yeah, let me double check if maybe we have here the clarifier, which is here in, but no, I don't see it. So that means we are really off frequency, and that is of course a problem. Okay, so what does it mean now for our next steps? Well, obviously this radio is really out of tolerance, and that means we will give this radio an alignment, and we will hope that then the radio will be back working. I mean, this radio is definitely not brand new. It is already vintage, and that means that we may not able to get the radio back into tolerance by using the internal alignment elements, simply because the components have aged, and that means that sometimes it doesn't work. And that on the other hand would mean it is not repair any longer, then it is definitely restoration, and that is something what the old man don't want. So he told us if it is possible to fix it as a repair, and if it is possible by alignment, everything is fine. But if it turns into a restoration, we would not go ahead. So let's see what we can do, and if we are able to bring it back by our internal elements. Alright, we already done here our first steps to perform our alignment, and what you see down there, so that is a PLL board where we need to start with, and that is already a little bit difficult, as you can see that there was this board on top of the PLL board, and you see that was already a little bit tricky to get it out of the way, to get down to the board, and to do our first PLL alignment steps. And as you can see, I have moved over here to my trusty Agilent, because it is a little bit easier to read, simply because we have more digits, and yeah, you see it is basically the same result what we have seen on our Rakal Dana as well. So it is approximately 4.5, 4.4 kilohertz off, and of course that is something we definitely need to bring back into tolerance, and therefore we have to go our way through to all the PLL alignments. And therefore you see that it starts here, and really that we need to go really over all these tests. Very important is of course here our LO output, which we have to take at test point P3, right, and we need to read 483, but now I've seen that already here our first step is not 100% intolerance, so that is our log voltage, and we should have on 1240, which you can read here in FM mode, 0.8 volt, and when we go down to our meter, it is already a little bit off. Yeah, and you see it here, so we should need to adjust it to 0.8 for the lowest frequency here on our radio, and therefore, as I said, we go through. I do not show you now every single step, because we already have a video on where we go along. I just only show you when there is really a huge error which we really need to align, and then of course we look deeper into that, and maybe that already our LO output frequency might be off, because our difference of 4.5 kilohertz, so that must be, or that must have a reason, and therefore, yeah, let's go into the steps which are really crucial and which are way off, right? Well, already getting down to the test point for LO1, which is below here, this little box. You really have to take it here apart, as you need to get under the PCB, right, to desolder here our little tin in order to get here to the test point. And that already, you know, is a little bit of a nightmare, right? because you see you have here HF wires going here through the radio, and they are so short that you really, like this one here as well, that you really can't move this thing only a bit. And yeah, now I have to take off here the lid, right, to finally get down here to this area, and you see we have here a shielding as well, which we need to get off first to be able to get down here to the solder points where this is here soldered to, and then I might be able to get down. Then I have to assemble it back into place, that we have finally back all of our connections, which we need of course to do our measurement. And you see that is already very, very time consuming, and yeah, it is annoying. Wow, and we cannot really believe it. You know, it is not only here at the top and the bottom soldered. Now we have here another solder point, and again another one here under this shield. So it is not only that we need to take off this shield, what we already have done, so we need to lift this one here as well in order to get here to the fourth point, what we really need to unsolder to get our shielding off. Wow, that is really not very service friendly. So that is a nightmare. But we really need to get down to that test point, because that is the only test point, at least, where we can check and align our LO1, which is absolutely important. Right, and yeah, here you see now our 4 solder points which we needed to unsolder, and I really hope that I can now get off the shielding from the other side. So that is incredible. Right, so let's see. And yeah, I had to unsolder this connection already, and now I can get it off. Unbelievable. Very nice. And now I get really down to my C-31, I believe. Let's see. Yeah. So what you can see down there, so that is the test point where we need it to go down. Alright, so what I have to do now, I have to bring it back all, that yeah, I can connect it back to where it has to go, and then I can start testing and aligning. So that already costs me 20 minutes. That is unbelievable. Okay, but we are making progress here with our service and friendly Icom. So our next steps was that we have to align both the output level of the crystal LO output and the frequency, right? Both was really off. Most critical was our output level, so it was 25 dB down, and that is really a lot. And you can see it here once again. So maximum output is more than 0 dBm. And just to remember what that means, 0 dBm is 224 millivolt, And if we go down, minus 25 dBm means only 12.6 millivolt. And you really see the huge difference, what really makes a difference for working or not working. So that was able to achieve. And secondly, we had to align here our 483.0300 megahertz, and that was off as well. And so that means to correct this frequency means it is one part of bringing back our frequency, which we have found, what was it, approximately 5 kilohertz off, right? And we all know that 5 kilohertz, especially when we're talking about SSB, is really far too much. So therefore, yeah, let me show you what we have achieved. First of all, you see the frequency which we had to set, and you see 483.0300, which is a requirement, and we really have the both 00 behind our 3. You can clearly see that, and that is really good news because we were able to bring it back. Secondly, as I told you, we need to obtain our 0 dBm, and let's see what we have done there. Okay, so very easy to see it here on our spectrum analyzer. So I've set here our center frequency to 483.0300, and this line here, horizontal line, is 0, and up here we have plus 10, and we need to cross the 0 line as given in our service manual. So let me go down here to our test point, and whoa, I need to get the right contact. And what you come on, what's going on here? So, and what you can see is, first of all, 483.0300, which is what we were looking for, and you see we have plus 1.6 dBm, so that means over 0 dBm. And now the parameters for this setting is simply perfect, and yeah, we can go ahead. Right, our next step is here the second LO, and I can pick the second LO here at this cable, which is coming, of course, from our PLL circuit from the other side, right? So I've already picked it, and service manual is telling us better than minus 10 dBm must be the output which is present here at that test point. And here we have it, minus approximately 7 or minus 4. You see it is jumping back and forth a little bit. Is definitely better than minus 10, so therefore we can say the output level is just fine, so no problem with our second LO. But the frequency is another story. So we should have 123.110 megahertz, and well, you can see we are off, I don't know, 780, 800 hertz, and definitely that is another finding, because these frequencies are all mixer frequencies, which will at the end mix up to the higher frequency, and therefore if you have already an error in the lower mixer frequencies, then that will be even more at the target frequency. So therefore it is really important to bring that frequencies right in order to have at least the right output. Yeah, and that is now just fine. 123, 110, 0, which is fine, and yeah, we can go ahead. Okay, so the last what we had to do here on the PLL board is to adjust here the doubler, and that was really way off. So we didn't achieve really, yeah, we were so far off that we really need to increase the output level here from our doubler, and that is now fine. So that we have finally finished all the settings on the PLL board, and we can bring here everything back. So yeah, that we are finally going to make progress and can go over to the next board. Alright, and before I now put back all the shielding to our PLL board, I just doing here a final check to the pre-adjustment we have done on our PLL board, and what you already can see, so we put in 1296, so we dialed it in at the radio, and we are checking here the output frequency out of the radio, right? And what you see is that depending on the temperature, so you see the radio is still creeping up a little bit in frequency, but you see our frequency error here on FM, so it's set to FM, is by in the moment it is approximately 50 Hertz, and we have not finalized our settings. So there are some more settings on the main board which have to be done, and you see for FM 50 Hertz is great, because the delta, the allowed delta on FM is approximately 200 Hertz or so, so that is something you would not recognize. But by now the huge difference we had of almost 5 kilohertz is solved, so that is already fine, no problem whatsoever. So we really can go ahead, and yeah, I can really go and put all the shielding here back to our circuit, and you see transmit light is still on. Now when I switch it back to receive, yeah, that is really promising, and let's go ahead. Okay, so sure enough, this shielding here has to go back, and of course here our main shielding, which goes here on the button and on the bottom, and then we bring it back into the housing, and we can stack here our other PCB over it, so as we found it, and yeah, so let me do this job here to get really rid here of our PLL board. That was really no fun, to be honest. Alright, now we are already on the main board to do here the next steps, and first of all we are aligning the transmit BFO frequency to really get on frequency on FM. So you have seen that we was a little bit off, and now we do here the fine tune to get exactly where we want to, right? Alright, so what you see here is our 1296, right? Which is almost achieved. So you see we need to align it here just a little bit. So that is what I'm doing here, and you see I can really bring it here to frequency, and that is exactly what we are looking for. And yeah, so you see we are really able to do it. So that is yeah, okay, so it is bouncing back and forth, so that is normal, but you see our frequency arrow is really small, so that is fully acceptable, right? Yeah, and now we are aligning our lower sideband frequency, and the frequency what we are looking for is 10751. What is it? 150. So 10751, 150, and yeah, let's see if we can go down there, and 751, and yeah, you see, so that was really huge, our arrow, but now we are getting closer. So you get the idea. So this is very, very touchy, as that is a capacitor which needs to be aligned. So 10 hertz off, and yeah, I do that off camera because, as you have seen, it takes too long and it is touchy. But as I told you, so we always find test points where the frequency is off, and therefore it is really no wonder that you know, the radio was that far off. And so we are really almost ready with this radio, and you see how nice it is getting back, right? Alright, so all settings has been done. So radio is really ready to go. So we have aligned the entire TX circuit, and of course you have seen we have done the frequency, and so it's fine. Here once again our frequency, which is fine, as you can see, so no problem whatsoever. And our output power corresponding to the frequency. So let me switch here in, and you see 10 watt, which is absolutely in spec. Alright, and to get the testing of course complete, I have tested here our receiver as well. So a radio is receiving fine. The S meter is adjusted, so it's really ready to go, and that means we are at the end of our video today, and I stop it here. Thanks for watching, catch you next time, bye.